Hi, this is Peter Rajkumar, who's going to explain the array implementation of stack data structure. Now, if you see, what do you mean by stack data structure? Stack is nothing but a stack is a linear data structure, which can be actually preliminarily understood like as for a real-time application like a stack of blocks or a pile of blocks. Every block as it placed over top of one another in order to create a stack. Otherwise, a CD rack is also a very good example for stack. Same particular way to stack data structure is the same similar way it could be understood. Stack was also linear data structure. Now we know each and every file of blocks, each and first that we inserted kept in the stack will be at the last. Will be removed from the stack because we remove the first block, the total stack will be disassembled. So we have to remove the last block we have placed over the stack in order to maintain the stability of the particular stack. The same particular way stack data structure, this linear data structure, the same particular way it works because each and every element is pushed in the stack will the data item that was last in the stack will be removed first because the stack always works in LIFO principle, that is last in first stack. Now, and then I implemented the stack data structure with the help of C++ programming. C++ programming and coded the program in such a way that it's a menu-driven program. What do you mean a menu-driven program is it always based the input. I mean, user's input. Whatever user want to do, I mean, user want to push a data item into the stack, otherwise insert a data item into the stack, otherwise remove a data item into the stack, delete a data item into the stack by performing pop operation. Otherwise, want to display all the elements in the stack data structure. So for that purpose, the computer program is coded in such a way that the computer will ask the user for these respective options that are coded here, respective options that I coded here, respective options, four of these options, and user based on the user's input, which will be stored in another particular variable, and variable, the computer could run a particular designated operation in order to push a value into the stack or to remove an element from the stack. The pop operation display all the elements in the stack. And otherwise, don't want to perform. If the user doesn't want to perform any of this operation, he can exit from this particular program too. And so it's coded in such a way that's why it's called many driven program. Now, as anyone who's from C++ programming know, it was and the header file as IO stream using namespace standard. After that comes the declaration part because always the present program statement in C++ always consists of variable declaration. Here I'm declaring an array. Now according to the syntax of array declaration, because array holds because if you see the definition of array holds all the possible more than one value, which actually belonging to a certain data type. Holds lots of values, which is actually more than one, belonging to a certain data type. Because of this, we a crucial role played by this array, and also has each and every indexes for each and every element stored in the array. For that purpose, we are able to implement standard system with the help of an array. Now, here in the first line programming statement, I'm going to declare array. Given the int keyword, that means the array holds all the values belonging to a certain data type called integer data type. Now, stack is the name of the array, and inside the parentheses, I'm giving 5. That means the size of the stack or array is actually 5. Only constant number can be passed according to the syntax of array declaration. Now this 5, the size of the stack or size of the array, has been initialized as a value to another variable called n. Because we know that the array indexing, each and every element stored in the array, array indexing always starts with 0 to n minus 1, the size of the array minus 1. So here, the size of the stack is 5. That means only 5 elements can be pushed into the stack. That means the each and every array indexing array positioning will take place from 0 to the total size of the array minus 1. But for that purpose alone, we have to check whether the stack is actually full, whether the stack is actually empty, doesn't contain any data items in the stack, either the stack is overflowing or underflowing. Otherwise, each and every can be easily found out when we have a variable which denotes each and every value on the top of the and each and every value which is actually called as an array indexes. We can easily determine the stack is overflowing or underflowing, and the stack is empty. The purpose alone I did this. After that, it is a default variable top is -1 because the stack is empty. Initially, the top value will be equals to -1. After that, three user defined functions are defined in order to perform three of the operations that the user want to, to push a data item into the stack. Otherwise, remove a data item, delete a data item from the stack with the help of pop operation. Otherwise, display all the elements in the stack. Now, we know that actually execution always starts in C++ programming from each and program statements encrypted within the main function. Now, the first line of program statement always consists of declaration. I declare two variables called ch and val, where all the values belonging to integer data. Now, cout is the output statement in C++ programming. That means whatever I encrypting within the cout statement, within the double quotes, will be printed as it is in the output screen and output display the screen in the computer. For that purpose, I given C1, so it will print as a pushing stack. After execution, it will go to the next line program scene because of new one character, pop from stack, and so on up to pop from stack, after the display stack, up to exit. Uh, and after the university of checking any particular condition, and the do while loop will be executed once. That's why I use it do while loop is extremely crucial in that because I just want to push an element into the stack. That means top value should be incremented by 1 plus 1. The stack is not empty, just want to push. So you want to perform one push operation, it should be performed. So for that purpose, without checking any condition, do while loop will be executed at least once. So for that purpose, I given use do while loop here. So in then the do while loop, using CM statement, another CM statement, the entry choice, and as it is output screen and this is completed. Now by getting into the user, I using C statement, using C programming. I'm getting into the user for ch variable. So as a variable, and they take the instance, and the user is giving the value for ch as 1. So that means go over here, print actually enter value to equals the data to be pushed in the stack. After getting into the user for val, which holds the value which need to be pushed into the stack. Now I'm calling the user defined function, program defined function over here. That is here. And exactly calling the user defined function, and the former parameters, actual parameters, values are copied, called by value, and use a simple if and else statement over here, and checking the value top of the stack's value is greater or equal to n minus 1, because we know it should be greater or equals to, it can be equals to size of the stack minus 1. In this particular case is 4. Otherwise it should be greater than that, because if the stack overflows, that means no data item can be inserted in the stack further anymore. So for inside this if statement is coded here, if the condition is true, this part will be executed. Otherwise, if it's not, stack is not overflowing, it's empty. So I can push a data into the stack. So top value initially is -1, the stack is empty. Top value is increment by +1 is 0. Now I'm pushing the data item val's value in the top value 1. So then the 1 top value, the stack will denote as 1. I'm pushing the data item 2. Now, after pushing data item 2, what I'm doing here is, if the user wants to pop a data element to the stack, he is giving input as a CHS2. So a pop operation here, so the control will switch over here. So it's coming over here, and if part will be executed, offset is equals to -1, less than minus under 0. That means the stack is underflowing and the stack is empty. No data item is there. So no data item is there, the stack out in the wall. You can even remove the data element from the stack. For the purpose of the given, if the stack is not empty, you will go to the else part and you will print and the pop element is which should be value denoted by the top of the stack, which is inside of the stack right now, will be printed over here. And the top value will be decremented, because once the element is popped, the top value should decrement. After that, I'm checking actually this case 3, checking the print the data items in the stack. So what I'm going to do is the control is going to switch over here. So a display function, the top actually value should be equal to 0. That means the stack will have at least one element in the stack present in the stack. So then the stack's element will be printed with the help of this for loop as I coded in this code. If the user doesn't want to do any of this operation, he can give the input as 4. He can exit in the program itself, because the while condition is ch value should not be equal to 4. Once it's equals to 4, the loop will break and the program is also terminated. If the user is giving more than 4, that means it's invalid choice printed as it is output screen in the computer.